Hello, in this video we are looking at tangents and normals to a point. So I want to start with defining each of these words. So we're going to define what the tangent is and what the normal is, and then we'll do an example. So this is for learning intention 22, and to refresh our memories, let's go over what the tangent and normal are. So let's say I've got my set of axes here, and let's say I have some curve. Here's my curve, and I'm going to call that curve f of x. So the tangent is at some point. So let's choose a point. Let's choose here. The tangent is the line. It's a straight line that just skims that point. So let's draw in what the tangent is. So it just skims, it just touches that point. Let's draw in the tangent. And tangent actually comes from, it's the same like word origin as like tango, kind of to touch, like, I don't know, tango is quite intimate if you do the tango. So think of that if you want to remember what the tangent is. So it just skims the curve at that point. So that line is the tangent line at that point. So we call that the tangent. Now the normal is the line that's perpendicular to the tangent. And if we remember, perpendicular means it's at right angles or 90 degrees to the tangent. So it crosses through the tangent and it makes an angle of 90 degrees there. That's called the normal. So we have the tangent and we have the normal. So now that we know what they are, we have to be able to find equations for them. So let's make up an example. So consider, let's consider the curve. Consider f of x equals 2 sine 2x. Let's find the equation for the tangent and normal at x equals pi on 8. So notice here it's not asking you to sketch any graphs. It's asking you to find the equation of the tangent and the equation of the normal. So the first thing you do with any of these problems is you make sure you have an actual point. So notice here you just have the x equals, you just have like the x equals part here. Well, we need the coordinates for the point. So let's find out what y equals. So let's find the actual coordinates of the point. And we do that by subbing into our equation here. So we go f of pi on 8 equals 2 sine 2 times pi on 8. Let's see, well, 2 times pi on 8 is pi on 4, so we have 2 sine pi on 4 there. Okay, so we know our exact values. We know them very well because we've memorized them. Sine pi on 4 is root 2 on 2. So we know sine pi on 4 becomes root 2 on 2. Well, we have 2 times root 2 on 2. So I'm going to cancel these. And that leaves us with root 2. So let's be clear on what we've found so far. We've found the coordinates of the point. So the coordinates are pi on 8, root 2. So if this were f of x, which it isn't, but suppose it was, we've found the coordinates of that point. We've found the x value and the y value. That's what we've found so far. Sometimes the question will already give that to you, but you need to be able to know how to find it, because sometimes it won't. So you have the coordinates of that point. Now, to find the equation of a line, we need the gradient. We need to know what the gradient of the line is. So to get the gradient, well, we've got an equation here. We need to find the derivative. Let's take the derivative of this function. F dash of x equals, well, sine diffs to cos. That 2 is going to go out the front, so it's going to become 4 cos 2x. Okay, so let's find the gradient when x equals pi on 8. F dash of pi on 8 equals 4 cos 2 pi on 8, and 2 times pi on 8 just as before is pi on 4. And we know our exact values because we're very good students. Cos pi on 4 is root 2 on 2. 4 times root 2 on 2 is 4 root 2 on 2, which equals 2 root 2. Okay, well, you found a quantity here, you found a quantity here. Well, what do they mean? When you're doing these questions, make sure you remind yourself constantly what you're actually working out. Over here, you found the coordinates of this point. Over here, you found the gradient of this line. This is the coordinates of the point. This is the gradient of the line. So we haven't answered the question yet, because it wants the equation of the tangent. Well, to find the equation of the tangent, we need to think about what the tangent actually is. The tangent is a line, and the general equation for a straight line is y equals mx plus c. You should be able to put that down on your page with no hesitation. That is the equation for a straight line. We know the gradient of our line, it's 2 root 2. So we can sub that in for m. So we know y equals 2 root 2 x plus c. We're almost there, except we need to know the c value to define our line. To solve for c, we use our point. We know that this point is on the line, just as we know it's on the curve. So let's sub this point into here and solve for c. Well, y is root 2, and when y is root 2, x is pi on 8. So let's sub in pi on 8 plus c. Now we need to solve for c, so we're going to subtract this quantity from both sides. So we have c equals the square root of 2 minus 2 root 2 pi on 8. We can tidy that up a little bit. Let's see, we can leave the root 2 there. We can multiply this part out. 2 root 2 times pi on 8. And that equals, well, we can simplify the 2 and the 8 there. So we can have root 2 minus pi root 2 on 4. That's your exact value. You could factorize. You can leave it like that. You could factorize. Your calculator might give you something like this. They might take out the root 2 and leave you with 1 minus pi on 4 like that. That might look a bit nicer, but that's fine. There. So what does this all mean? It means we can write the equation of our tangent. We have the c value. We have the m value, so let's write the equation. I'm going to make some room here. Let's write the equation. The equation is y equals 2 root 2 x plus root 2 minus pi root 2 on 4. That's our tangent. Our tangent line is this here. So let's make that very clear that that's one of our answers. That's the equation. That's the equation for the tangent. 2 root 2x plus root 2 minus pi root 2 on 4. That's great. We've found the tangent. What about the normal? How do we find the normal then? Well, let's make some room here and let's do it. Let's find the normal. If I can find the right tool. Here we are. It's this one. Let's clear this. Let's just make some room here. Okay, so we want to find the normal. Well, the gradient for the normal, I'm going to call it m sub 2, is the negative reciprocal of the gradient of the tangent. So that was a lot of words. Let's break that down. Here's the gradient for the tangent. Over here, we found it before. It's this 2 root 2 business. So we need to take the reciprocal, 1 on 2 root 2, and which means flip it over, and we need to put a negative sign, the negative reciprocal. So that's the equation, that's the gradient of our normal at this line here. We're good students, we like to rationalize denominators. So let's multiply the top and bottom by root 2. What do we get? We get negative root 2 over, that's going to work out to be 4. Great, we've got the gradient of our normal. What's the equation for a straight line? So when I say what's the equation for a straight line, what should immediately pop into your head is y equals mx plus c. Let's write that down. Y equals mx plus c is the equation for a straight line. And this time we're finding the normal, so we're going to sub in this gradient. So we have y equals negative root 2 on 4 x plus c. Alright, so the gradient changed, but if you look here, this point, it's shared by the curve, it's shared by the tangent, and it's shared it's shared by the tangent and it's shared by the normal. So you use that point that we found before again. So let's use that point in here. We have root 2 equals negative root 2 on 4. Whoops, made a mistake there. It's negative root 2 on 4. Pi on 8 plus c here. Alright, we need to make a little more room. Let's clear some working. Let's just clear this out of the way. Whoops. Where's my pen? Here's my pen. So we want to solve for c once again. Well, we need to add this quantity to both sides. So we get root 2 plus root 2 on 4 pi on 8. And we can tidy that up a little bit. That's pi times root 2, which is pi root 2. And 8 fours are 32. So we've got the c value. We've got the gradient. Let's write the equation for the normal. So the normal looks something like y equals negative root 2 on 4 x plus root 2 plus pi root 2 on 32. And that's the equation for the normal. If that seems like a lot of steps, it is. But each step is something you can already do. So finding a point you can already do, finding a gradient from a derivative you can already do, finding the equation of a line you can already do. With a bit of practice, you should get quite quick at it. So it's really a matter of practice rather than any kind of, I don't know, it's a lot of steps. So make sure you get those steps down. But how do you check your answer? Well, let's grab the trusty CAS. So your CAS calculator can actually do all those steps for you. And you can do it with one function, which is very cool. So we'll just wait for this to load here. Alright, so what function am I talking about? We looked at this one last year, but if you go to menu, and if you pop down to calculus, here it is, you can go down to tangent line. Now, this function takes 3 inputs, or 3 arguments. You put in your equation, so we have 2 times sine 2x, whoops, 2x. You put in your equation, you put in the variable of your equation, which is x in this case, and you put in the point that you want to, whoops, it's dropped off a bit there, you put in the point that you want to find the tangent at, so that's pi on 8. So let's put in pi on 8, if we can find pi on 8. Alright, and if I've done this correctly, we should get an answer. Let's check it. So our tangent is 2 root 2. Yep, see, they've done their fancy factorizing there. Yeah, that's actually the same thing. They've just times the top and bottom by 4 there and grouped it into a single fraction. So that's correct. If you multiply the top and bottom by 4 and group that together, you'll get that same number there. So try that as an exercise. So if tangent line finds the tangent line, you guessed it, normal line will find the normal line, and it takes the same arguments. You can type normal line, or you can go to menu, calculus, and down to normal line, which is A. Oh, what did I do there? Menu, calculus, let's go down to normal line. Okay, so I could type it out like that. Another way you can do it, you can be a bit cheeky. You can pop up here, you can press enter, and if you ever pop up and highlight something and press enter, it grabs it again. Let's try a different way. Let's change the word tangent to normal and see if that works. N-O-R-M-A-L, normal line. There we are. Let's check that. Where's our normal? There it is. Yep, -2 on root 4x, and this is positive, and you can see they've made the denominator there the same to stick it together. So that's an exercise for you. See if you can combine these quantities by making the denominator the same, factorize and get that answer. So you can see that it's pretty straightforward to check your answers on your CAS. Lots of steps to memorize. Please go through it. Please get confident with a lot of practice. And if you have been, thank you for watching.